Hello everybody, this is RESHMA Devi Tiwari came in front of you with another new video to explain about optical activity. Right? So optical activity means certain crystals like quartz, sugar crystal, etc. They rotate plane of vibration. They rotate plane of vibration. Already in my last lectures I explained you about plane of vibration. Plane of vibration means that plane which contains the vibrations of the plane polarized light as well as the direction of the propagation of a plane polarized light. That plane we call it as plane of vibration. And the plane perpendicular to the plane of vibration we call it as a plane of polarization, right? So now such crystals like quartz, sugar, etc. they will rotate the plane of vibration. Let us see whether really they rotate the plane of vibration or not. Okay, so this phenomena of rotation of plane of vibration itself we call it as optical activity. Okay, this phenomena we call it as optical activity. Okay, so now here I took the Nichols prism. 2 Nichols prisms I took. And now on this I am making some the light to incident on it, right? Now after refraction, so this is Nichols prism, this is Canada balsam. It splits into the plane polarized light split into 2 rays, extraordinary and ordinary ray. Ordinary ray will be absorbed. Here also the same thing I am drawing, right? Okay. Now extraordinary ray, it comes out. And now this is plane polarized light. It came out from this nickel. This is the second nickel. How I placed second nickel? In crossed position. In crossed position means perpendicular to the plane of first nickel. Now here is the observer. He will not find any light coming out. Okay, the field of view will be dark when the second nickel is placed in crossed position to the first. So no light is transmitted, field of view is dark. Now in the second case, in the same position I kept the second nickel. Now I placed a quartz crystal in path of this plane polarized beam, and here is the observer. Now he finded, see here, the light is coming out. The light is coming out. Means here field of view is not dark. So I didn't change the position of second nickel. How it was in first, in second case also it was in such a position only. But here what I did? I placed a quartz crystal in the path of plane polarized light. So now in first position we didn't find any light coming out, but in second position some light has emerged out. Field of view is not dark. So what happened here means this quartz crystal has rotated plane of vibration. So only what happens? The light enters. So now the light transmits. the plane polarized light. As plane of vibration is rotated, this plane transmits from the crossed nickel. Now just rotate this nickel. When you rotate, again you will see field of view is dark. When you rotate, again you will see that field of view is dark. So this suggests that the light coming out from crystal is plane polarized. Actually, the light coming is plane polarized. But here what happens? This quartz crystal has rotated plane of vibration. Due to that only the light has emerged out and we are seeing that light. So this phenomena we call it as optical activity. And here you see the rays in such a way. So now next, the angle through which plane of vibration is rotated. Plane of vibration is rotated. We call it as angle of rotation. Angle of rotation. Now Biot, a scientist, has said some facts related to this optical activity. First one. So he said that there are two types of optically active substances. How many types are there? Two types of optically active substances. Some substances rotate plane of vibration or plane of polarization. Polarization is perpendicular to the vibration, plane of vibration, in clockwise direction. How they rotate? In a clockwise direction. Okay. So such substances we call it as dextro-rotatory or right-handed substances. Okay. And some substances rotate plane of polarization in anti-clockwise direction. Anti-clockwise direction. Such substances we call it as levorotatory substances or left-handed substances. Left-handed substances. The second fact given by Biot is the amount of rotation. Amount of rotation, theta, is directly proportional to the thickness travelled by the light. Amount of rotation produced is directly proportional to the thickness through which the light has travelled. Okay. The third thing said by him is the amount of rotation is directly proportional to the concentration of solution. As concentration of solution increases, the angle of rotation increases. If it decreases, angle of rotation decreases. Next, the amount of rotation is inversely proportional to the square of wavelength of light travelled. Square of wavelength of light travelled. Next, if he said that if we take some different optically active substances in which the amount of rotation is for first substance θ1, second θ2, so on, then the total amount of rotation produced by different optical active substance will be equal to the summation of angle of rotations produced by individual substances. Alright. Now these are the 5 points said by Biot. Now let us define what is specific rotation. Specific rotation, it is denoted by S. Theta, what is theta? Angle of rotation or amount of rotation of plane of vibration. Of plane of vibration. Right? Let L be the length travelled by the or length by the light in solution in some decimeter. Okay, and if C is the concentration of a solution in gram per cc, then specific rotation is defined as the rotation or amount of rotation of a plane of vibration of a plane polarized light produced by 1 decimeter length of a solution when concentration is 1 gram per cc. 1 decimeter solution when concentration is 1 gram per cc. Alright. So specific rotation equal to theta by LC. So unit becomes theta, degree, by length, decimeter he said, and gram per cc. Right. Now let us see the Fresnel's theory for optical rotation. Fresnel's theory for optical rotation. So Fresnel said that the linearly polarized light is nothing but the combination of two circularly polarized lights. Polarized to the resultant of two opposite circularly polarized light vibrations of same frequency. Frequency will be same, but amplitude half of the amplitude. Half of the amplitude. It is the combination of two circularly polarized lights with same frequency and half of the amplitude. Now according to him, the first thing he said that when a beam of a plane polarized light enters into the crystal along optic axis, it breaks into two circularly polarized lights. It breaks into two circularly polarized lights with vibrations, one with clockwise, other with anti-clockwise direction, with their vibrations, one in clockwise and other in anti-clockwise direction, one in right-handed or other in left-handed, we can say. Okay. Second point, he said that in optically active substances, like quartz, the two circularly polarized vibrations, they have different velocities. Okay, or they travel with different velocities. If we take dextrorotatory substance, then the velocity of right-handed circularly polarized light will be greater than the velocity of left-handed. Okay, If we take levorotatory substances, the velocity of left-handed vibrations will be greater than the velocity of right-handed, or left-handed vibrations will be more faster than right-handed vibrations. The third point he said is that in optically inactive substances like calcite, calcite, these two circular vibrations have same velocity. Circular vibrations will have same velocity, right? And lastly he said that after emerging out of the crystal, again these two vibrations recombine and give rise to the plane polarized light. They recombine and give rise to the plane polarized light. The plane of vibration rotated. The plane of vibration rotated, we call it as angle of rotation. Okay? And this angle of rotation totally depends upon phase difference introduced between them. So these are the points said by the Fresnel. Thank you. If you like my video, like it, subscribe it. Stay with my channel Reshma Physics for receiving the new videos with the new topics related to the B.Sc Physics which are useful for the M.Sc Physics entrance exam. Thank you.